In this video, I will explain how to create an adjacency matrix for a graph. So let's say that we have this graph right here. We can see that this graph has 5 vertices, A, B, C, D, and E. Now, this graph offers a useful way to visualize the relationship between the different vertices as a diagram, but sometimes we might be interested in representing a graph using only numbers, or we might want to store the graph in a database using only numbers. One way to do that is to create an adjacency matrix. Now, as the name implies, this is a matrix where the column names are the vertices in the graph. So in this case, we have A, B, C, D, and E. And the row names are also the exact same vertices. So A, B, C, D, and E. Now, within this matrix, we're going to fill in zeros and ones to indicate whether or not different vertices are adjacent to each other. So let's just focus on this first row right here with vertex A. So first we'll ask ourselves, is vertex A adjacent to vertex A? So in this case, we're assuming that we're working with a simple graph. And in a simple graph, there are no loops, such as a loop like this, where an edge could be connecting one vertex with itself. So in this case, we would say that a vertex cannot be adjacent to itself. So we're going to put a 0 right here in this square. Then we'll move on to the next column. So we'll ask ourselves, is vertex A adjacent to vertex B in the graph? So if we look at our graph, we can see that vertex A is indeed adjacent to vertex B, or in other words, there is an edge that connects those two. So because there's an edge that connects them, we're going to put a 1 right here in this box. And then we'll move on to C. So is vertex A adjacent to vertex C? We can see that it is within the graph, so that gets a 1. Then we'll ask, is vertex A adjacent to vertex D? Well, we can see there's not an edge that connects those two in the graph, so that will get a 0. And then lastly, we will ask, is vertex A adjacent to vertex E, which we can see it is not. There is not an edge that directly connects those two. So this will also get a 0. So all we're going to do is just repeat this process for vertex B, C, D, and E. So here's what that looks like. So here's what our final adjacency matrix will look like for this graph. Now, there are a few interesting properties about an adjacency matrix that I should mention here. The first interesting property is that the sum of a row or a column is the degree of that vertex. So for example, if we look at this first row in our adjacency matrix with vertex A, if we take the sum of all the values in this row, that turns out to be 2. And that is the degree of vertex A in our graph. Now recall that the degree is just the number of edges that are touching that vertex. So in this case, we can see that there are indeed 2 edges that are touching vertex A. So vertex A has a degree of 2. And similarly, if we look at the column that contains vertex A, if we take the sum of the values in that column, that also turns out to be 2. Or if we consider vertex B right here, if we take the sum of the row values, that sum turns out to be 3. And that is indeed the degree of vertex B in the graph, because there are 3 edges that are touching vertex B. The second interesting property about an adjacency matrix is that the diagonal values are all 0. And we mentioned that earlier because each vertex cannot be adjacent to itself. So we'll notice that the diagonal values in this matrix are all 0 because A cannot be adjacent with A, B cannot be adjacent with B, and so on. And then the last interesting property about an adjacency matrix is that it is a symmetric matrix. So we look at each of the diagonal values in the matrix, we'll see that it is symmetric about the main diagonal. So that was just a quick example of how to create an adjacency matrix for a graph.